Hello students, how are you doing today? I hope you're having yourselves a wonderful weekend. Today's lesson is actually a two-part lesson. It's kind of chunky. It might take a while. I'm uncertain. I'm going to do this in two parts. Part one is going to be called function notation. Part two is going to be domain and range. And I'm going to do it in two parts. So in case you don't need one lesson, maybe you do want the other lesson, you can decide for yourself. But let's get started. So like I said, today we're doing function notation and domain and range. And the first thing I'd like to talk about today is function notation. I think to understand what function notation is, it's better to start with what is not function notation. And you have already dealt with function notation, with not function notation in your life. You're used to seeing this. Y equals 3x minus 2 with a y with an x. It's just normal old equation. And you may be asked to find y when x equals 4. And you've done this before. You take the x, you plug in 4. 3 times 4 is 12, minus 2 is 10. You get an answer of 10. So that is what I would call not function notation. Now, function notation, there's only one tiny difference, and it has to do with the y. Instead of using the y, they use this term f of x, which is in the bottom shelf there. I have students doing quiz retakes. You should do your quiz retakes if you'd like. So instead of using the y, I'm going to use the f of x, and it's 3x minus 2. So it's the exact same equation, except instead of using x's and y's, I'm using x's and f of x's. And then what's nice about function notation is that it's very efficient. This find y when x equals 4, it's very wordy. And math people, we don't like words because we like numbers. So if I wanted to ask this exact same thing but in function notation, I would just say f of 4 equals, or I guess maybe because it's an instruction, find f of 4. And what that's telling you is go through this equation, and everywhere that you see an x, you plug in 4, and you end up with 10. So that's an example of function notation. You will see this within graphs too. Usually you'll see an x-axis and a y-axis, but if you're using function notation, this would be the x-axis, and this would be the f of x axis. So that's just kind of a quick intro as to what function notation is, and then let's just do some quick examples to show how you could use this. So suppose g of x equals 8 minus x squared. Let's call this example 1. Part A, it asks me to, typo. It asks me to write g of 3. Sorry, my notes, I wrote the wrong thing on my notes, and I have to, it's causing me to be a little absent-minded for a couple seconds. Give me 5 seconds to get caught up with myself, please. Excellent. Crisis solved. So g of 3. So I'm going to take this equation, and everywhere I see an x, I'm going to I should use math terms. Substitute. I'm going to substitute in 3. So 8 minus substitution, 3 squared, which becomes 8 minus 9, which is, of course, -1. So that's what you do when you need to plug in a number. Sometimes they don't ask you to plug a number into a function notation equation. Sometimes they ask you to plug a letter into it. They'll say something like g of n. Same thing. You go through the equation, and everywhere you see an x, you change it to what they're asking you to. In this case, it's n squared. Next, if there needed to be any kind of simplifying, you'd want to do simplifying at this point, but this problem doesn't have any other simplifying, so we're going to leave it like that. Part C. Sometimes they'll put 2 questions into one. G of 2 plus g of 3. So this is like 2 little problems put into one. So first we're going to go through the equation. We're going to plug in 2, 8 minus 2 squared plus, now we're going to do g of 3. So same thing, we're going to go through the equation with a 3, 8 minus 3 squared. Following your order of operations, 8 minus 4 plus 8 minus 9, and then all addition from left to right. 8 minus 4 is 4, plus 8 is 12. 12 minus 9 is 3. Yay! Okay, and that is a multi-step function notation problem. I have 2 more parts, or 3 more parts. Oh, totally doing these problems out of order, I'm realizing. Part D, sometimes they're not going to give you a positive number, sometimes they're going to give you a negative number, g of negative 4. The one thing with that is just be careful with the negative here. 8 minus, because this x is being squared, this negative 4 needs to be in parentheses. And then you go 8 minus, follow order of operations, negative 4 squared is 16, and 8 minus 16 is negative 8. This is a great time to bring up an extremely common mistake that people make with their calculators. This ultimately might become Elliott pet peeve number 2, and it has to do with when you're squaring numbers, and this isn't a good reason to not use your calculator in all honesty. We squared negative 4 in this problem, and when we squared negative 4 times negative 4 is positive 16. We know that. But sometimes you're like, I don't want to use my brain, I just want to use the calculator. You must put the negative 4 in parentheses. Negative 4 squared, and you'll get this positive 16. If you forget the parentheses and you go negative 4 squared like that, the answer is going to tell you negative 16. Yep. Calculator's telling the truth. And let's just explore that really quickly. If you go negative 4 squared, what you're really saying here is negative 1 times 4 squared. So following your order of operations becomes negative 1 times times 16, which becomes negative 16. So yeah, you got to use your parentheses. So if you're going to square negative 4, that is equivalent to negative 4 times negative 4, which is positive 16. So if you're going to use your calculator to square a number and that number happens to be negative, you must use the parentheses, because calculators, just like people, follow the order of operations. Part Elliott, backwards problem. Find x when g of x equals 4. And friendly reminder, g of x is equal to 8 minus x squared. And in this case, they're telling me what g of x is equal to. So I'm going to change this g of x to a 4 equals 8 minus x squared. And then it becomes an algebra problem. Solve it algebraically, subtract 4 from both sides. Negative 4 equals negative x squared. Divide both sides by negative 1. X squared is equal to 4. Square root both sides. Do not forget the positive negative. X equals positive or negative 2. Sometimes there will be 2 answers to these problems. And last part of this first one, part F. Let's say that I had 6g of 1. I said 6g of 1, Elliot? 6g of 1. Okay, so in that one, this is telling you 6 times, I wrote x again, function of g of 1. So we're going to do g of 1. Let me bring down this equation one more time. Here's my equation. So I have 6 times g of 1. Use parentheses. Because g is everything that's going on g is happening together. 8 minus 1 squared. 8 minus 1 squared is 7, and 6 times 7 is 42. And that is that's just a brief introduction into function notation. Just another way of writing out An x to y equation is your function notation. And that basically concludes part 1 of today's lesson. Part 2 of today's lesson is going to be in domain and range, and I'm going to start that lesson in like 15 seconds. See you in a couple seconds, everybody.